Hello guys, so we are going to continue a discussion with respect to Python programming language, and now we are starting a new model which is called as multi-threading and multiprocessing. This is a very important topic for all the Python developers or any other developer out there, because these are some of the fundamental core concepts to write more efficient code whenever you are developing an application. So in this video, we are going to discuss about all these topics that I have written over here. We'll be discussing about what is a program. Then we'll go ahead and discuss about what is a process, then what is a thread, and some of the examples with respect to processes and threads, right? And then in the upcoming videos, we will be seeing some practical application with respect to multi-threading and multiprocessing. So let us go ahead, and here what I'm actually going to do is that, first of all, I will go ahead and give you a basic definition of program. Okay, so what exactly is program? Okay, so till now you have written so many different kind of code, script, you have used Jupyter Notebook, but if I really want to give a specific definition for program, it is nothing but a program is a sequence of instruction written in programming languages. Now, programming language can be anything. In our course, we are basically learning about Python. So here, some of the examples that you can use as a programming language, it's nothing but like Python. Then go ahead and use C, C++, anything that you want. Okay. So it is nothing but over here, a program is a sequence of instruction written in a programming language, and it gets executed based on, how the program is specifically written. Some of the example over here, if I probably consider, so let's consider Google Chrome, right? Now, Google Chrome is a kind of a exe file. It is an exe file, and right now it is an application if you have installed in your Windows. In Mac, it may be in different format, but at the end of the day, this is nothing but, this is a sequence of instruction. Over here, we write some kind of program and we say how this particular browser should work, right? How this browser should work. So this is nothing but an example of a program itself, right? So Google Chrome, the entire application is written with the help of some programming language. It has a lot of sequence of instructions that is written, which basically shows that how the browser should work. Okay. Similarly, the other example is that you use Word, you use Excel, right? So these are all different programs. Okay. Now let us go ahead and discuss more about something called as process. Okay. Now, if I really want to write the definition for process, okay, so what exactly is a process? And in this video, I will be discussing completely in depth with respect to this, so that you'll not have any confusion. So here, a process is simply an instance of a program that is being executed. Okay. So what exactly is a process? A process is an instance of a program. So let's say I have Google Chrome. If I double click Google Chrome, so a process will get started, right? A browser will get opened. Similarly, I can open any number of browsers, right? So each and every browser with respect to Google Chrome is a process, right? But what we are actually doing over there, we are just creating an instance of a program, right? And that is how each and every application is basically opened. Now, with respect to process, you need to understand one thing. It works along with the OS, right? Because it will definitely be requiring a lot of computer resources. Now, those resources will be shared within the process. Now, some of the resources that is actually required, I'm just going to write it down over here step by step. So first resource that you actually require is nothing but the code segment. Okay, so let's say this is my code segment. This code segment is basically the code that is required to run this particular process. So it will be, as I said, it is an instance of a program. So this program will be available in this code segment. Then you have something called as data segment. Data segment has the list of all global and static variables, so that wherever in the program it is required, it will be able to access it. Then you have something called as heap memory, right? So over here, with respect to this particular heap memory, you'll be able to see that dynamically allocation of the memory will automatically keep on happening, right? Then along with this, a process will also share with stack and registers. Stack is going to make sure that it has the access of all the local variables, function calls. It will be able to have that, right? And if I talk about register, these are nothing but these are smaller memories to keep, so that it will be able to store some of the variables, some of the logics that is basically written over there for a smaller period of time. So register is nothing but it will be having a small space of memory, so that whenever that kind of temporary memory is required, it will be able to store it. Okay. So this is entirely a process, and process usually requires this kind of resources, right? Now, if I talk about more about the process, right, along with this. So here you see that I also have registers. Okay. Now every process, when we run it, right, this will have a separate memory space. This will have a separate memory space. Let's say that I am opening Google Chrome, right? So it will be allocating a separate memory space for one browser. Similarly, for the other browser, it will be allocating another memory space. Okay. Because of this, since it has a separate memory space and separate memory space is allocated, here you can see that one process cannot corrupt another process. This is important. Okay. This is one of the core feature. And why it is possible? Because over here you have a separate memory space, right? So one process, if I'm running Google Chrome browser, like let's say I have opened a Google Chrome browser instance, and similarly instance I've actually created it. If one browser faces some problems, the other is not going to get closed. Okay. So here is one example. So, and why this is done? Because if it is using a separate memory space, one process is not going to corrupt the another one. Okay. Now, you'll be able to see that since it has a separate memory space, so let's say it requires some other IO requirement, right? IO resources requirement, right? Now, during this point of time, because of this separate memory space, you'll be able to see that this will be one disadvantage, that there will be an increased execution time to switch between processes, right? From one process to the other process. Let's say I'm working in one browser, then again I want another browser for that point of time, and let's say the other browser has some kind of other requirements, other resources requirements, right? Let's say IO, or it can be any other resources. At that point of time, you'll be able to see that the execution time will increase, since we are switching from one process to the other process. So this is all together to understand more about the process itself. Now let's take some super cool example. Let's say I have browser. Browser is one example that we can consider. We can open any number of browsers. Then let's say I have an Excel sheet. I can open this Excel sheet. So this will be opened in the form of process itself. And each and every process has its own ID when we probably launch this particular instance. Similarly, any exe file or any installation that you have done with respect to the app, right? That can be, whenever you really want to start it, it will be started as a process. Okay. More to talk about it. What I will do, I'll just go ahead and open my task manager. So here in the task manager, here you can see there are different processes that are running. Calculator is there, Google Chrome is there. See, Google Chrome 88 browsers I have, which I'm running right now. And again, because I keep on exploring multiple things, I'll be able to see Notepad++ is there, OBS Studio is there, Scribble is there, where I write my notes, right? Every folder is opened as a process, right? And here also you can see background processes are also there, right? Let's say I want to probably go ahead and see this particular, like how much CPU memory disk is basically used. I can go ahead and check it out, right? So these are some of the example with respect to the processes. Okay. I hope you're able to understand this. Now let's go ahead and discuss with respect to threads. Okay. Now threads is also important, and we will be using daily threads also, even while we are using our laptop or desktop also. So what exactly is a thread? Okay, so first of all, to give a definition, a thread is a unit of execution within the process. Within a process. Now, what does this basically mean? So let me just go ahead and take this again. I'll take this as an example. So here it says that, hey, thread is a unit of execution within the process. Okay. And with respect to thread, there are also multiple types. The first type I will go ahead and write over here, which is called a single threaded process. Now in single threaded process, right, you'll be able to see that there will be a single thread. Okay. So I'm just creating this particular thread like this. Now this thread will have its own stack and register, but it will be sharing the code segment, data segment, and heap from the process itself. Okay. Thread is nothing but it is a unit of execution within the process. Okay. In order to understand thread, okay, let's take an example. Let's say I have opened MS Paint. Now in this MS Paint, let's say I want to go ahead and create a rectangular box. Now in order to create this will be first of all opened as a process. Now to perform this operation, I can actually go ahead and create a thread. I can select an option over there to create this rectangular box. When I click it, a new thread is basically getting created. And with the help of that particular thread, I will be able to create this particular box, right? Similarly, let's say I want to go ahead and create a circular box. Again, I can go ahead and again create another thread just by clicking one option, and then another thread will be created, and this circle can be created like that. So here, this is executing as a process, and here you can basically see we are creating threads to do most of the tasks within this particular MS Paint, the process that we have opened, right? So this is a perfect example to probably understand, right? Similarly, you have Excel sheet. Let's say I want to do the bold for all the characters. So I'll select an option, and over there thread will basically get created within the process. Okay. If I say single threaded process, that basically means I'll just have one single thread. But if I say multi-threaded process, okay, multi-threaded process. Now in the case of multi-threaded process, you will be seeing that everything will be same, but here we will be having multiple threads. So let me just go ahead and copy this, paste it over here. So in this case, what we will do is that here, I'll just go ahead and write like this. Let's say I have multiple threads. Let's say I have 2 threads over here, right? So this is my first thread. This is my second thread. Now, as I said, threads, what it happens is that it will be using its own stack and registers. Since these are executing independently, this will also have its own stack and registers, and remaining all the thing, it will be sharing it along with the process. Okay. So here you can just understand the basic difference between thread and process. And I have also told you an example with respect to any functionality. I'm able to open it. I'm able to create a thread, and it is doing that specific functionality, right? If I talk with respect to process, it can be a browser, it can be any application, that everything we open as an instance of a program, it is basically getting executed. Okay. So this was a basic idea with respect to thread and process. And here we have also explained some of the examples of process and threads. So I hope you were able to understand this particular video. In the next video, what I'm actually going to do is that I'm going to show you with the help of Python programming language, how can you achieve multi-threading and multiprocessing. But right now, these basics are very much important for you all to understand. So yes, this was it from my side. I will see you all in the next video. Thank you.